Hi, welcome to BYJU'S 12 board series. I'm Himanshu and today we are going to discuss about optics, which includes ray optics and wave optics. Then we have dual nature of matter and atoms. All right. So what I'm going to do is we have this 15-minute session. So I'm quickly going to go through the chapters and tell you what are the important topics and in what way you should prepare different topics. All right. So let's start with reflection, which is in ray optics. In reflection, you have basically the law of reflection. That's something which you have been learning since your 9th standard. So you shouldn't have a lot of problem in learning that. And see, whenever laws of reflection is asked, there are two statements mentioned. Both the statements always draw a diagram. One of the most important thing in optics is always draw a diagram. And I've seen my colleagues cutting marks of the students when they have drawn diagrams and they have forgotten to put the arrows on the rays. Okay, so please be careful in doing that. And when you make a mirror, you have to like specify which side is the reflecting surface and which side is the painted surface. All right, so be very careful with that. Now, what else we have in reflection? We have reflection at plane mirrors, that the object distance is equal to image distance. That idea you have to be very clear with. Practice how to make a ray diagram. That object is given, you should be able to predict where the image would be. You know that there is a lateral inversion case of plane mirrors. These kind of questions can be asked as 1 markers, all right? Or they can also ask a 2 marker where you have to draw where the image would be given a position of the object in front of the mirror. Then in reflection we have curved mirrors. In curved mirrors, basically all you have to remember is the mirror formula: 1 by V plus 1 by U is equal to 1 by F. What is V? What is U? What is F? F is equal to R by 2. What is R? What is C? All these terms related to a curved mirror should be very clear in your mind. And whenever you get a question, which you can get a theoretical question where you have to derive the mirror formula, right? The derivation can also be asked. However, it is not asked too much. But what I can expect more is numerical questions. And when you get numerical questions, please don't forget to draw diagrams. All right, without a diagram you'd lose half the marks. And along with drawing diagrams, be very clear about like positioning the image, the size of the image that will be formed, and all these things. There's also a formula for image height, which is basically the magnification formula in case of curved mirrors. Please go through it very properly, because the sign convention is very important. So in general, the sign convention in this chapter is very important. See, optics is a chapter which is not much about formula. Optics is a chapter of precision. Okay, so you have to be very precise in what the things which you're doing. Then we have refraction, and in refraction you have basically you start with like the Snell's law, the laws of reflection, the Snell's law. So they can ask you as a 2 marker, what is the Snell's law? So you'd have to tell, you have to write the Snell's law, and always write that with a diagram. Don't forget that. I'm repeating it again and again. All right, that the light bends, when does it bend towards the normal, when does it bend away from the normal? All those things have to be mentioned very clearly. The normal has to be drawn very clearly, right? So these things matter a lot when you're writing an examination which is subjective. Now there is an idea of critical angle. Be very clear with what critical angle is, that the ray is going from the denser to the rarer medium. What is total internal reflection? How is total internal reflection different from regular reflection? Why is it the word total there? Okay, and you can get questions of what are the applications of total internal reflection, what are its real life applications or uses. This is a very commonly occurring question, which is a 2 marker question, right? You can also get a question as a numerical in critical angle. You have to remember that the critical angle is the sine inverse of the the refractive index of the rarer medium divided by the refractive index of the denser medium. Talking of refractive indices, you can also get a question of what is refractive index, or the definition of refractive index. This could be a 2 mark or a 3 mark question. Remember that refractive index has something to do with the speed of light. Remember that formula and write it down very clearly and precisely. All right. Then in refraction we move on to lenses, and in lenses you have this lens formula, which is 1 by V minus 1 by U equals to 1 by F. You can get a question where you have to derive this lens formula from the laws of refraction, right? That is also something which is there in NCERT, and you should prepare, because that's a 5 marker. If it comes, you shouldn't skip it. and then there in lenses you have the lens maker formula, right? The formula to find the focal length, 1 by f equals to 1 mu2 by mu1 minus 1 by r1 minus 1 by r2. Be very clear what is mu2, what is mu1, what is r1, what is r2. How does the ray, which is the incident ray, which is the refracted ray, which is the first medium, which is the second medium, which is the negative side, which is the positive side, the sign conventions, everything should be very clear, right? So they can sometimes for 1 marker or 2 marker they can ask you to state this formula, or they can also ask you to derive this formula, right? That the parallel rays, when it strikes a lens, where do they fall? Then related to critical angle and total internal reflection, you have phenomena in real life which is called formation of mirages, right? So how does a mirage form? That is also a question which the board likes to ask a lot. Whenever such a question is asked, always supply it with a diagram, because it's important. Okay, that what happens, how is the refractive index of air changes as you move up and all that, right? Then you have a section of prisms, the dispersion of light, what is the angle of prism, how is the angle of prism related to the internal angles, what is the condition of minimum deviation, what happens to the incident and the emergent ray, or the angles, incident and the emergent angles in the condition of minimum deviation. All these questions can be asked. Always draw a diagram. So almost every part of optics, I feel you can be asked a question, and it's a very big topic. I would suggest you especially to remember in front of a curved mirror or a convex lens, for different positions of object, what is the position of the image? This is a direct question that can be asked. You should be very clear with what is the definition of an object, what is the definition of an image. Can a real object form a virtual image? Can a virtual object form a real image? Is that possible? In this particular case, what kind of image will be formed? So all these kind of questions you can expect from the chapter of optics. All right. Now coming to wave optics, it's not a very big chapter, but wave optics you obviously have to know the Huygens principle or the Huygens principle. So once you know the Huygens principle, you state the Huygens principle, you draw the diagrams, the ones with the wavefronts, the circular wavefronts, that diagram, state clearly what it means, and maybe you can give an example of a diffraction or interference happening somewhere, which in real life, which states or which kind of gives you an example of Huygens principle in real life. But the center of this chapter is not Huygens principle, it is the Young's double slit experiment. So you have to be very clear about the setup of the Young's double slit experiment. How does the setup look? What is a small d? What is a capital D? What is Y? What do we mean by fringes? Which is the central part? What is a dark field? What is a bright field? What is the condition for constructive interference? What is the condition for destructive interference? Right, that if the overlap happens such that the phase difference between them is an even multiple of 2 pi, even multiple of pi, right? So it's a constructive interference, otherwise it's a destructive. Otherwise, in the sense, if it's a multiple of pi, then it is a destructive interference. So all those ideas must be really clear in your mind. You must be clear with what are coherent sources, right? You can get a 1 mark or a 2 mark question on what are coherent sources. So that also is something you have to prepare. Now another thing in YDSA is certain times you have to do some derivations, and if you start doing derivations right there in the examinations, you will not be able to do it, or if you do it, you take a lot of time. So please practice the derivations beforehand. And please be very careful with the assumptions of Young's double slit experiment. There are many assumptions which go along in the Young's double slit experiment. So these are some important topics from wave optics. I think that I have already told almost the entire chapter, because these two chapters are really important. Then we come to dual nature of matter. In dual nature of matter, again, this chapter, the core of this chapter is photoelectric effect, right? So you have to be very clear with what were the observations of photoelectric effect, the diagram which goes along with it, the one in which the rays come and the electrons are going to the other side, and the circuit is there with an ammeter and all that. And you have to be very clear with what were the failures of classical physics, right? Because classical physics predicted something that didn't happen. You get direct theoretical questions of like asking you what failures of classical physics came out to be, or classical optics came out to be when photoelectric effects observations were made, right? So you have to write 4 or 5 points depending on how many marks that question contains. If it's a 2 marker, write 2 points is fine. If it's a 5 marker, write 4 or 5 points. All right. Then observations, failure of classical physics. Then the next thing is the results of photoelectric effect. So the results of photoelectric effect have also to be properly understood, and the diagrams are important, and E is equal to h nu, that formula you have to state, and that formula, which is the kinetic energy of the electrons which are coming out, is h nu minus the work function, right? What is the work function of a metal? That is also a question that can be asked. In fact, it is asked a lot. Okay, so the core is photoelectric effect. Simple problems in photoelectric effect where there is a photon with this much energy. Then this is the work function of the metal in which we are striking it, right? What will be the maximum kinetic energy of the electrons coming out? Those kind of questions. The question that the fact that the intensity does not depend on the frequency, but the intensity depends upon the number of photons, right? So sorry, the current depends on intensity, which is the number of photons. So that is also an important fact, and don't forget it. This can be again asked in a 1 or 2 marker. All right. So photoelectric effect is the most important thing. Then you have Debry's hypothesis that matter also behaves like waves, and how to find the wavelength in terms of momentum. It's a very simple hypothesis which he gave. A couple of lines you have to write about it, and whenever a Debry's hypothesis is asked, please supply it with the formula, right? That is about dual nature of matter. There's nothing much. Basic idea, the basic thing which you have to do is photoelectric effect. Okay. Then we come to atoms. Atoms is more like a story. Whenever, I think if you've read NCERT or any other book, or if you've gone through our videos, you see that we teach it like a story, because it's like a historical trivia, like not a trivia, like a historical journey of what have been happening from our end in trying to understand the nature of atom. So we start with Dalton's atomic theory, Thomson's model of the plum pudding model. Sometimes they can ask you what is Thomson's plum pudding model, what was the failure of Thomson's plum pudding model. The important thing here is the Rutherford model. The Rutherford model setup. The setup is very important, that it was put inside a lead case, and it was a gold foil in which it was being emitted, and like what were the angles at which that there is an angle sign formula. That formula you have to remember. And what were the results of Rutherford's model? What did it conclude? That nucleus is in the center. All those points you have to be very clear with. And the diagram of the Rutherford model is also very important, and also the fact that maybe 1 in 10,000 alpha rays were actually coming back, right? Then after that you have once you are done with Rutherford model, what you learn next is Bohrs model, right? And Bohrs model is also one of the important things in atoms. In Bohrs model, what was the basic assumption of Bohrs model? Why did he think that what are the stationary orbits? What is the condition for being in stationary orbit? What do we mean by quantization? Okay, so these kind of questions can be asked related to Bohrs model. And Bohrs model, remember the drawbacks of Bohrs model is also important, which is a very commonly asked question. What are the major drawbacks of Bohrs model, right? The major drawback would be like that it is valid only for a single electron atom, and that it could not explain the Zeeman and the Stark effect and all those. So these are the major things you can expect from the chapter of atoms. So there I have covered all of this. See, the point is, I feel that, remember that in every chapter there is an important part which you have to be very careful with. For example, in photoelectric effect, you have to be very careful with the graphs, right? They can ask you graphs, and they can ask you graph based questions. They can ask you also to draw a graph between the stopping potential and the incident frequency, between the intensity and the current, and all those things. So all these are important. See, if you have prepared for boards, of course you have notes. Go through your notes very properly. But the thing is, many times I find that students who already know all these topics, they write them down, but they are not able to score marks because they are not writing it very clearly. They forget to mention examples. They forget to draw diagrams. If they don't draw diagrams, I don't know where their mind is. They don't label it. Just by labeling it, you get an extra half marks. Okay, so be very careful with how to label these things. All right. So this session was not about teaching you concept. This session was more about like a brush through through all the topics of these chapters. and what are the important things and where you need to put focus. All right, so I think I'll take some questions here. So Sandeep is asking what exactly do I need to study in critical? Okay, fine. So he's asking what exactly does he need to study in the total internal reflection and critical angle. See, one question which was asked in CBSE, which is commonly asked, is like the fish example, where there's a fish and to what radius can the fish see. So that's very simple. You have to draw a ray diagram, and the ray goes out, and then you have to draw a perpendicular there, which is a very commonly taught idea. So that kind of question you can expect. You can expect what is a critical angle, and you can also get a question, a 1 marker question that from like is it true that that total internal reflection happens when light goes from rarer medium to denser medium, which is false, right? It always happens from denser medium to rarer medium, not the other way around. So these kind of simple questions can be asked. They can directly ask the definition of critical angle, which is the angle in the denser medium for which the angle in the rarer medium becomes equals to 90 degrees. Okay. Now Torque El Capone, crazy name, dude. What type of numericals are expected from atoms and nuclei, especially reactivity and postulates? So we do a separate session for nuclear physics. There I'll tell you what are kind of questions you can expect from nuclear physics. But from atoms, you can expect in boards numericals as such. You can, from atoms, you can expect some numericals from Bohrs model, right? You can expect like some numericals on the energy, which is the like the 13.6 electron volt formula, that energy formula, the velocity of an electron in different orbit, that kind of formula. But see, in competitions they ask a lot of questions on this, but in boards they don't ask very detailed questions. But apart from numericals, you can expect a lot of theoretical questions from this chapter for sure. All right. Then Shobharup Sarkar is asking how to understand ray diagrams. How to understand ray diagrams is, we don't have that much time. Now I suggest you to go through our videos. We have covered that very beautifully. How to understand ray diagrams, how to interpret ray diagrams, how to draw ray diagrams. All right. But you have to draw ray diagrams. That's the point I want to make here. So Torque is again asking, is in case of diamond ray of light passes from rare to dense medium, then how is it due to phenomena of TIR, since it disobeys one condition? No. Yes, in diamond, from air to the diamond, the ray is going from a rarer medium to a denser medium. But when it is trying to come out of the diamond, then it is going from a denser medium to a rarer medium, right? And there is when the total internal reflection happens, right? Not when it is going from air to the diamond, when it is going from the diamond back to air. Mohammad Faisal is asking important topics from optics, also other important topics. I think that's what we discussed. Ajay Kumar is asking, what is Mirage? Please full clarity. Okay. So dude, you have to like sit and understand what Mirage is, but a basic understanding which I'll give you is this. See, light bends when it moves from a medium which is of one refractive index to a medium of different refractive index. So what happens in deserts? There is this layer of air, and because of because the desert is hot, right? The ground is hot. So what happens is there are different refractive index of the refractive index of air itself varies as you move up. Okay, because of which what happens, the light which is traveling, it keeps on bending as it moves through the air, right? And then in the end there is a total internal reflection, and because of which it starts moving in the upward direction. So what happens, there's a tree on one end, and because the light from the top of the tree comes this way, and then it bends because of total internal reflection and reaches your eye, you feel like the tree is there, because see, you observe the thing to be at a place from where the light is coming, not where the thing is actually is placed. Okay, so if you're standing in front of a mirror, if your friend is also standing in front of a mirror, if you don't know that there is a mirror, you would feel that your friend is standing right in front of you, if you're not unaware that there's a mirror in front of you, right? So that's the idea. But of course this is not enough. You have to again, I'll say that you watch our videos to clarify the concepts themselves. Now Torque is again asking, if we use derivation of YDSE as shown in your videos, would we get full marks, or we have to go through binomial theorem? I think the YDSE derivation which we have done, that is I think that the derivation we have done, I don't think that is a derivation which is other than the derivation which is there in NCERT. So you can go through that derivation. But you can also go to the derivation in NCERT. See, I won't say that the derivation which is there in our videos is wrong. But the thing is, I would suggest, honestly, I would suggest to do, if there is even a slight change in the derivation which is there in the NCERT, do the derivation which is there in the NCERT. Because see, a lot of people who are checking the paper, unfortunately, are very inflexible, okay. Sometimes I even feel that they don't really get this thing, the idea. Otherwise they would give you marks if you do it in another way also, because in the end you're deriving it. But don't take that chance, okay, because they're going to see line by line the things which are given in NCERT. So please please follow that. And yeah, so those were the questions. So thank you for joining us today in this session. I hope this was helpful, and we'll see you again. By the way, please go through the videos. Please download our app. I've already told you that. You can go through our YouTube channel also, and there you'd find a lot of fascinating videos, and you'd find that same level of engagement and creativity we have brought into almost all our videos that you'll find when you download our app. Thank you.